Selenium Grid is a powerful tool for handling cross-browser testing, whether on a local machine or in a distributed environment. But setting it up in a cloud CI/CD pipeline can be tricky, so let me walk you through it. For this demo, I'm using a basic Java Maven environment from GitHub. I'll grab the repository URL and import it into Gitlab. This demo focuses on building with Maven, but I'll also point out how you'd do the same thing with Gradle, Python, NPM, and other build tools. I'm using a MacBook for this video, but nothing here is really macOS specific, so you should be able to follow along easily on Windows or Linux. Now that it's in Gitlab, the first step is to clone it to my local machine. Always run your tests locally first. It's way easier to debug issues in a local setup before moving everything to the cloud. Here's the test in my code editor. It's pretty straightforward. If you've written test scripts before, you'll see what's going on here right away, and even if you haven't, you'll pick it up quickly. The test goes to the Sauce demo website, logs in, and checks the page title. This test uses a local Chrome driver, but for Selenium Grid, we need a remote web driver, so I'll comment out the local driver initialization. We'll need to import a few classes, remote web driver and browser options. I'll import options for Chrome, Firefox, and Edge so we can set up cross-browser tests later. We'll also need the URL class for instantiating the driver. Here's how you instantiate a new remote web driver. You give it the Selenium hub address and the options for the browser you want to use. I think the URL method needs a try-catch block, so I'll add that. Looking good. Now let's create the pipeline. I'll create a YML file named .gitlab-ci. If you've ever created a pipeline in the GitLab web interface, this is essentially what it does behind the scenes. It creates this file, and when you commit it, the pipeline starts running. We'll use the Docker latest image because we'll be composing 3 simple Docker containers. I'll add just a test stage. In a real scenario, you'd have build, lint, deploy, etc. We need the Docker din service. Din stands for Docker in Docker, which allows us to run Docker commands within the pipeline. The script will have just 2 lines. First, we compose the hub and browser node. Docker compose up will build and start the containers. The detach flag runs the containers in the background, while wait performs a health check and ensures everything is running correctly before proceeding. With Docker Compose Run, you can run a one-off command inside a service. We're using Maven for building and running tests, so the command is mvn clean verify. If you're using Python, you'd put your Python command here. Similarly, for Gradle or NPM, you'd put the appropriate test command. You might be wondering about these containers, but don't worry, we'll create them in a Docker Compose file soon. Just remember their names: hub, Chrome node, and tests. Finally, we'll add artifacts, defining files we can download. I'll define the Surefire reports directory as an artifact so we can see the test report. Next, we create a Docker Compose file. Here we'll define and configure the 3 containers. First, we configure the Chrome node. All tests using Chrome options will be redirected here. You can specify the Chrome node image as latest, or if you want to test a specific browser version, you can put that version number, or if you want to use the public beta, you'd use beta. I'll define the platform as Linux AMD 64 since I'm running on a Mac. Depending on your hardware and OS, you might need to specify the platform or not. The depends on parameter ensures that the hub starts before the Chrome node. We'll need 3 environment variables: host, publish port, and subscribe port. These tell the node where the hub is and which ports to use for communication. They're the default ports. Now, let's configure the hub. We'll use the latest Selenium hub image. When I name this container my hub, I can set the correct event bus host in the Chrome node. The last step here is to expose some ports, which are the default ones needed for communication between the hub, the node, and the test. The final container we need is for running the tests. You can specify whatever image you use for your test environment. I'm using the latest Maven image, but for Gradle, you'd use the Gradle Eclipse image, for Python, the latest Python image, and for NPM, the node latest image. The working directory will be set to app, and we'll mount the current directory to this location. This means the tests container will use the current folder for reading test scripts and writing test reports. We're almost set for the first local test run. Before that, I'll update the POM file with the latest versions of Selenium and TestNG. Tests would run with older versions too, but it's good practice to keep them up to date. Now I'll start the hub and the Chrome node. With Docker PS, I can confirm the containers are running. Then let's run the tests. We have an error here. This is actually good for you to see. It's a common error when configurations are off. Cannot invoke WebDriver because this driver is null. Usually this happens if the hub address is incorrect. The address was wrong indeed. It should be my hub, not localhost. Let's run the tests again. And there, the build succeeded. Just to make sure, I'll make the test fail intentionally. I usually make the test fail on an assertion and leave it that way. When prototyping a CI/CD pipeline, it's more informative to see how a test fails. And there's the expected error, wrong labs. We've now confirmed we can run this on a local machine, so let's shift to the cloud. We need to use one of Gitlab's predefined environment variables, CI project directory. This is the base directory of the repository. We'll mount this instead of the current directory. Then, I'll push everything to Gitlab, and the pipeline should start running. Let's see if everything's configured correctly. The test failed as expected, with the wrong labs assertion. If you want to look at the test reports, just click the Browse button. Now that we've got Chrome working, let's add Firefox to make this a true cross-browser test environment. First, we'll duplicate the Chrome node setup and rename it to Firefox node, changing the image and container name. The test script needs one small change. We need a switch case block to decide which browser options to use. When running the docker run command, we'll give it a test browser environment variable as a parameter. This tells the test which browser options to use. Looks like I missed a brace. Next, we'll update the Gitlab pipeline. First, we'll add an environment variable parameter test browser set to Chrome. Then, we'll duplicate the Chrome job to create a Firefox job. We'll change the job name, the node, and the value of the test browser environment variable. We're all set. Let's commit and push. The Firefox run failed, but with the right assertion, let's check the Chrome job too. The Chrome job succeeded as well. We've accomplished our goal, but I want to show you an alternative approach. Looking at our pipeline, if you've worked with Gitlab before, you might think it'd be easier to set up the hub and the node as services. Believe me, I've tried it. No matter how I configure it, I always hit the dreaded Selenium grid not ready error. This could be due to incorrect network settings within the Docker image. I have some ideas about what might be causing this issue, but troubleshooting it would be too time-consuming, so let's wait and see if the Selenium team sorts it out. So, I suggest skipping Selenium Grid. Cross-browser tests are easier without it. Use Grid for specific needs, such as running Appium tests. But for normal cross-browser testing, use standalone browser images as services and an environment variable to specify the browser. It's a simpler setup, fewer lines in the pipeline, and no Docker Compose needed. To add Firefox this way, just duplicate the Chrome job, change the image, alias, and environment variable, and you're done. That's it for this tutorial. Hope you found it useful. If you did, share it with your colleagues. Catch you in the next video.